Hey everybody, this is Mr. Dollar, also known as Peace Daddy, and this lesson is going to be on the memorization of multiplication games. If you're working from home, you're going to use a website called virtualmontessorimaterials.com. Once you're at virtualmontessorimaterials.com, you'll see a lot of little boxes with pictures in them, and those represent the different materials you can use on that website. You're going to want to click on the box that says bead bars. Once you're there, you will have a box of virtual bead bars that you can use to play the following games. We're going to play the multiplication snake game, the create a table game, invert the factors, and forming squares. So I'm going to go ahead and move my camera down so you can see the rug. And the materials that I'm working with are the Montessori materials. So I'm going to be using a box like this that is filled full of the different beads that we use in Montessori. And I also have some 10 bars I'm going to be using for the first game. But those materials you will find on virtualmontessorimaterials.com, and you use them just like you use the beads in a Montessori classroom. So first game is called the multiplication snake game, and you're going to take out as many bars of the same color and make a snake with them. So you just choose as many bars as you like. So I'm just going to choose the 9 bars over here. And I have 1, 2, 3, 4, 5, 6 of them. So I'm going to use 6 9 bars. And I'm going to make a snake with them. So just like when you have the addition or the subtraction snake games, you just make a snake. Like that. And then once you make the snake, you're going to change the snake, just like you do in the addition and the subtraction games, working with 2 bars at a time. And after you get the result, you write it down. And you can do the control or the verification for this would be the multiplication table number 1, or you could use a calculator to verify that your answer is correct. So this is 9 taken 6 times. So you would write down on your paper 9 times 6, and you would use a counter. I just like to use a piece of an index card like this to count with, and you're just going to work through the different beads. Each time you get to 10, we know this one's 9, so the next bead right there would be 10. Each time you get to the 10th bead, you're going to replace it with a golden bead bar that represents 10. Okay, so we've got our first group of 10, so I'm going to go ahead and take this one and put it away. I don't need it anymore. Okay, and then I just begin counting again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I've made another 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I've made my third 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I've made another 10, my fourth 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. And that's my 5th 10. And then over here in the back, I have 4 left over. 4 beads that are left over. So I can't make another 10, and I'm gonna come over and get a 4 bead for the end of my problem. So what do I have? 10, 20, 30, 40, 50, 4. So 9 times 6 is 54. And that's called the multiplication snake game. You can just take out as many beads as you want, as long as they're all the same color, and then you make groups of 10. Okay, the next game is called using the bead bars to create a table. So for this one, I'm gonna use, you can use any beads that you want. I'm gonna use the 3s, and you're gonna take out 9 of them. Whatever color you use is fine, as long as you take out 9 beads, because you're gonna make your own multiplication table instead of looking at a table and answering the questions. You're gonna make the table. So 1, 2, 3, 4, 5, 6, 7, 8, one more, 9. Okay, so I have 9 of my beads, and the first one, this would represent 3 times 1, or 3 taken 1 time. So 3 taken 1 time is 3. And then I would take a second set of beads, and that is 3 taken 2 times, or 3 times 2, which is 6. And I've already started my chart. So 3 times 2 would be 6. And then if I take 3 times, that would be 3 groups of 3 would be 9. So that's using the bead bars to create a table, and you would go all the way down and record each one of those until you got to 3 times 9. The next game is called inverting the factors. And inverting the factors, this work is going to emphasize the commutative law. Okay, the commutative law. And I want to write that out so that you can write that down on your paper at home. Okay, the commutative law. And sometimes people call that the flip-flop law, and you'll understand that in a minute while we call that. But write that down. The commutative law can be emphasized using this game called inverting the factors. So just grab a few bars of the same color. I'm gonna grab 6 bars of the 7, and I'm gonna lay them out on my rug so that they form a rectangle. Okay, so 6 of the 7 bars. 1, 2, 3, 4, 5, and one more makes 6. And we're going to lay those out on the mat so that they form a rectangle, just like that. And then what I want you to do is you're going to need some graph paper, and you're going to draw that rectangle onto your graph paper just like it is on here. So going across, we'll have 1, 2, 3, 4, 5, 6, 7 beads, just like we have on our table, but we're gonna do it on our graph paper, so we're gonna go across 7 little squares. 1, 2, 3, 4, 5, 6, 7. Okay, so I'm just gonna go over that line one more time to show that those are my 7 bars going across. And I have 1, 2, 3, 4, 5, 6 of the 7 bars. So I'm gonna go down on my chart paper here 6 times. 1, 2, 3, 4, 5, 6. Just like that. And then once I have the bar name going across the top and the number of bars going down, I complete the rectangle. So I'm going to do the right side over here and then the bottom over there. And that would be 7 taken 6 times. So you're going to write the problem inside of the rectangle that you make. So next, you can take a look at the inverted factors, which would be 7 bars of 6. So whatever you did the first time, just do the opposite of that the second time. So 7 groups of 6. So now I'm going to do the opposite of that, and I'm going to do 6 taken 7 times. So 1, my 6 bar, 2 6 bars, 3, 4, 5, 6 6 bars, 7 6 bars, just like that. And I'm going to make that into a rectangle. And this time, we're going to make the rectangle with 6 bars going across the top on our paper. So over here on your paper, you'll go across 6 times. 1, 2, 3, 4, 5, 6. And then stop on that 6th square. And I'm just gonna go over it one more time to make my line nice and straight. How many 6 bars do I have? 1, 2, 3, 4, 5, 6, 7. So there's 7 beads going down this way. So that's how long I'm gonna make the line this way. 1, 2, 3, 4, 5, 6, 7. And we're making a rectangle, so we know that the rectangle on the right side is just gonna be just as long as the rectangle on the left side. So I'm gonna finish the left side or the right side and then finish the bottom. And then this is 6 taken 7 times. Okay, so now we're going to note that the answer to both of those problems is 42. If I count this one out, I'll get 42 squares, or the beads if I count them. And if I count this one out, I'll get 42 squares or beads, and I can count them. The final thing that you would do is you would get a pair of scissors and cut this one out and cut this one out and lay each of them on top of one another. So I'm gonna take some scissors and I'm gonna cut them out so that you can see that one of them will lay right on top of the other one and that they are in fact equal. So let's see. First I'm gonna cut out 7 times 6. Just like that, cutting really carefully. Cut right on the line. And then I'm going to cut out 6 times 7. 6 taken 7 times.
Do you like my Lego set? Do you like my Lego set?
Now that I have both of them cut out, I have 6 times 7 and 7 times 6. We're going to make a little magic here and show that 7 times 6 and 6 times 7, if you lay one of them right on top of the other one, they fit perfectly. They're the same. So that helps us to think about what's called the commutative property or the flip-flop property. If I take the 6 at the end of my multiplication problem and I move it to the front of the multiplication problem, and I take my 7 from the front of the multiplication problem and I move it to the back of the multiplication problem, the answer remains the same. And you can see just by turning the paper that I have 42 squares for 6 times 7 and 42 squares for 7 times 6. So that's called the inverting the factors game. All right, last game is forming squares, and you can select any bar from the box that you want, and then you lay out as many of this bar as it's worth. So let's say, for instance, that I chose the 4 bar. So if I choose the 4 bar, I'm going to lay out 4 of them. All right? That's how you play this game. Choose a bar, any bar, and then you lay out 4 of that bar. And you're going to note the shape. What shape is that? That's right, it makes a square. So then I would like for you to get a fixed square from the bead cabinet if you're in the classroom. If you're not, you can just notice by looking at it that that's a square. And then you can take the fixed square from the bead cabinet and place it on top of the loose one. And then you record the problem, 4 groups of 4, or 4 times 4 equals 16. And then you can draw it on the paper, just like we did with the last game with the forming squares game, okay? Or the inverting the factors game. So that's the last game. It's called forming squares, and you can do it with any of the beads. You just make sure that whatever the name of the bead is, if it's a 4, that you choose 4 beads. If you're going to choose a 8, then you would choose 8 of the beads. So 8 beads would look like this. You would do 1, 2, 3, 4, 5, 6, 7, 8. And that would make a square. And if you're in the classroom and you have a 8 square, you can place it right on top of that, superimpose it on top of the square so that you can compare the two. All right, that's the last game for today. And as always, thank you for watching. This has been Peace Daddy. See you next time.